Hi everyone, so we're finally ready to start talking about programming. And in this video, what we're going to do is introduce the concept of an expression and then look at our first statement, which is the assignment statement. We'll see how we can use assignments to store the results of expressions into named places called variables, and then use those variables in later lines of our program. We'll also explore a couple common pitfalls that people run into when they're trying to use variables. And all of this will get you ready to start writing your very first programs. So let's get started by talking about expressions. So this term might be familiar if you took an algebra class in the past. In algebra, an expression is just a short mathematical phrase that reduces down to a final answer. And when we use this term in computer science, we mean the same thing. An expression in computer science is a sequence of operations whose result can be expressed as one single final value. So here's an example that works in both. Say we've got the expression 3 plus 4 divided by 2. When we have 3 plus 4 divided by 2, we can break that up and simplify it. And because of our order of operations, we know we do division before addition. So we do that 4 divided by 2, and then we end up with the expression 3 plus 2. We can still simplify that. We can do the addition, and we end up with a single final answer, the number 5. So the computer is very good at doing this type of simplification. And what this means is anywhere in a program that we can put any literal value, any number, any text, we can also put an expression that reduces down to just a number or just some text, and it will actually do all of the work for us. However, unlike in math class, computer science is not limited to numeric expressions. We can write expressions with numbers, but we can also write them with text, or even the answer to yes/no questions, what are called Boolean values. We're going to spend a lot of time on Boolean values in a future video, but for now, the important thing to know is that we need to be careful when we're dealing with a text expression versus when we're dealing with a numeric expression. And the way that we tell a difference in most programming languages is with quotation marks. So this is particularly thorny when you're trying to write text that looks like a number. Usually your programming language, Python included, will tell you if you did something wrong when you try to add the word apple and you forgot quotation marks. But if you put the number 4 and you just put 4 exactly like that, then you mean the number 4. However, if you put quotation marks around 4, then you are saying the text that looks like the number 4. And if you recall, all data in programs, whether it's a number or text or colors or sound, it's all numbers at the end of the day. So quotation mark 4 is actually the number 52, which is the number we use for the text character 4. There's a bunch of invisible stuff before it that takes up all the lower numbers. So our numbers actually end up being much higher when we write them as text. So that is one thing to be careful about, is that when you are dealing with an expression, you need to figure out, am I writing text or am I writing a number? However, anywhere in your program that you can use one of these things, you can instead use something that does some work to produce one of these things, one of these expressions. So that's the concept of an expression. The way that we use these expressions most often is by doing assignment. So an assignment is the simplest statement in a computer program. An assignment is an instruction that we're giving for the computer to take some expression that we write and save it somewhere so that we can use that result later. The way that we write an assignment in Python and in most programming languages is first we put the name of a variable. We put some named place we want to save something. So for instance, if I wanted to save my user's first name, I might put a variable first underscore name. And the big rule in most programming languages, including Python, is that the name you give this variable has to start with a letter, cannot have spaces. So if you want spaces, we often use an underscore or clever capitalization to show you where word breaks would be. So I've got my first underscore name here. And then to tell the computer that I actually want to do an assignment, I put an equal sign. So I put first name and then an equals. And then on the right of that equals, I can put any expression that represents the number or text or Boolean or any data that I want to save into that variable. So if I put quotation marks Matt, what I am telling the computer to do is, in the running memory, go carve out a box for some data. Whenever I use the word first name, I'm talking about that box. And then take this text Matt, the result of this expression, which is already finished, it's already simplified, and save it into that box. And that is an assignment. So the reason that this is useful to us is on every future line of my program, once I've done this assignment, I can use this variable name just like I could use any other expression. I can even use it in part of an expression. I could write on the next line of my program, hello, quotation marks, plus first name. And if you notice, the first name here does not have quotation marks because I'm not talking about the text, literally first name. I'm talking about the place first name, the variable that has information stored in it. And when Python sees that variable name in that expression, it goes and does substitution. It goes, looks at all of its boxes of variables it's created in running memory and tries to find one with this name. And if it can resolve that name to a variable, then it fetches whatever is stored in that box. In our case, that name Matt, it substitutes in that Matt, and then it performs the rest of the expression. So it adds hello to Matt, and then the final evaluation of this expression would be the text that reads hello Matt all together. So this doesn't sound like a lot, but this is already the majority of programming. More than half the lines in a program are just going to be us pinning some intermediate step saying, oh, well, do all this work on the right of the equals and then save it into some place on the left. And then the next line, we use that thing we saved, do a bunch of work and save it on the left again. And we keep doing that with variables to make progress and store our little checkpoints of work done so far so that we can keep referring to them throughout the rest of the program. So that is an assignment statement. The other thing I want to talk about in this video is some of the ways assignment is unintuitive, especially if you're coming from a math background. If you've taken algebra and you've seen that equals for years and years, the equals in programming works slightly differently. So first, when we use an equal sign, we are completely overwriting whatever was previously stored in a variable. We can reuse the same name in the future, but if we do that, whatever was there before is completely erased. So let's say on the first line of my program, I write x equals 5. Then that's going to make a box in our running memory called x, and it's going to put 5 in that box. If on the very next line of my program, I write x equals 10, I've still only got one box named x. It can't reuse the name to refer to two different things, because then in the future, if I said, go get me x, it wouldn't know which one I was talking about. So when I reuse that name, it says, oh, well, there's something already here. Let me just throw that in the trash. It's going to scribble out that 5, and then it's going to store this new expression into there. It's going to store the 10. So now there's still just one box x, but instead of 5, now it's got a 10. And then in the future, if I use x, like say I say answer equals x plus 1, then when I go and fetch x, it's going to fetch only that most recently saved value. So the answer will be equal to 11. Even though there was at one point a 5 in there, the 5 was already gone by the time we fetched it out. So it was lost and that information was never saved. This is important to keep in mind, especially as our programs get more complicated in the future, as we introduce repetition and different pathways through a program. It's important to remember that only the most recently saved value is still going to be there. So you have to be careful with your names and only reuse something when you're completely sure you're done with it so far. So that is our first pitfall, is that reassignment deletes whatever was there before. So make sure you want to do that if you reuse a name. The next one I want to look at is a consequence of that, or rather it is something to keep in mind when we are doing this reassignment. So another common mistake that new programmers make is thinking that an equals stores exactly what is on the right of the equals, that it stores the work we want to do. In reality, the equals only stores the final answer. Computers like to try to save space, and all of the work that you want to do is sometimes space intensive, sometimes it's work intensive. There might be a lot of steps in your expression if you've got some complicated math in there, or you've got a whole bunch of parts of text that you want to squish together. So what Python and most programming languages will do is, when you've got an assignment statement, it is going to fully evaluate the expression and then only do the assignment once it has the final answer. So this is important when we're doing reassignment, I said. So here's an example to demonstrate that. Say on the first line of my program, I type name equals Frank. So if I do that, then I've made a box called name. I've put the text Frank into that box. On the next line of my program, I say the greeting equals hello plus name. So this is just like the expression we saw a couple minutes ago. Because there's a variable here, it needs to fetch that out. And so right now, saved in name is the word Frank. So it's going to fetch that. And now we've got hello plus Frank. But we're not done yet. We can still simplify that expression and turn it into hello Frank, one full line of text. That is a final answer. And only then does Python say, okay, we're ready to save that result. So once it has that hello Frank full sentence, then it is going to save that into the greeting variable. So at the end of this line, now we've got name equal to Frank, and we've got greeting equal to hello Frank. On the next line, I might decide to reassign name and say name equals Sally. So that's like our reassignment example before. We know how to handle that. we scribble out what's in name, so Frank gets deleted, and now the name box is holding on to Sally. But if I go to use this greeting in the future, say I try to print it out so I can see it, greeting didn't get notified of this update. Remember, we only stored the final answer. So this name variable, even though by the time we get here, it's storing Sally, the only thing greeting cares about is what was in name at the time that line number 2 here ran. And when line number 2 ran, name still had Frank in it. And so when I go to print out the greeting, it's going to print out hello Frank, even though the name has changed. So this is something to keep in mind when we're using variables. You have to be careful to consider what are variables storing when a line of code runs, not just what are they storing at the end of the program. In the future, we're going to have a video all about functions. When you have a process and you actually want to store the process and substitute in a value right when you do the assignment or the final instruction here, functions will allow us to express that. Functions let us store instructions to run at a given moment. But when we're just doing an assignment is always going to do the work first right now and only store the final answer. And that can have an impact when we're doing these reassignments. So that is the second thing to keep in mind. The last thing I want to point out is another break from algebra. And if you've been following everything so far, this one should be fairly obvious to you. So that is the fact that a equal sign in programming is not symmetric. So if you've forgotten what the symmetric property is back when you covered commutativity and associativity, don't worry. All symmetry says is that I can flip the order of things and it doesn't change the answer. So some operators like addition are symmetric. If I do 5 plus 4, that's exactly the same as 4 plus 5. Both of them give you the answer 9. However, there are operators that aren't symmetric, like division. If I do 4 divided by 2, that's a bigger answer than 2 divided by 4. So equality, the equal sign in algebra, is symmetric. If I do x equals 4, that's exactly the same thing as saying 4 equals x. However, remember, in programming, the equals symbol is not equality. It is actually assignment. And what it is saying is save the thing from the right in the place on the left. And that means the right and the left are doing different things, and I can't just flip them around because that changes the meaning. So as one last example, say here I've got a program where the first thing I do is x equals 5. So I've got that x box and I save the number 5 into it. And then next I say y equals 6. So now I've got a y box with 6 in it. And then on the next line, I say y equals x. So this is another example of a reassignment. I've changed what's in y. So I cross off what was there before, the 6, that is gone. And then I fetch what is in x, which is 5. So now y has 5 saved in it. Then if I do an answer equal to y times 2, that's going to be 5 times 2, and it's going to give me 10. If I do the exact same program, and the only change I make is instead of y equals x, I do x equals y, then I get a completely different answer. I start off the same, 5 in the x box, 6 in the y box, but x equals y is not going to change the y at all. It's going to change the x because the place on the left is the box that is changing, the variable that we are assigning a value to. So in this case, x is 5 actually gets overwritten with the 6. So when my answer is y times 2, I end up with 12, and I ended up with a completely different answer just by flipping the left and the right sides of this one assignment on line 3 of our program. Another example of this, something I have students do every single semester, is putting the expression on the left side. I see someone try to do 5 equals x. And if you do that, the program crashes entirely because you can't save a variable into a number. You can only save expressions into variables. If we tried to change what 5 had in it, that would break all math forever. We can't say, well, 5 is actually the word guitar. What would that do to multiplication and division and addition and subtraction? So you have to be careful when you're using equals that you remember the left is a location and the right is the work you're doing. So those are the 3 most common pitfalls I see. But otherwise, this shows you your first and most important instruction in programming, the assignment statement. So definitely start practicing this. You can even write meaningful Python programs that do nothing but calculate out answers. Say you have a variable in the top of your program that has some stored value, and then you write a formula to do something like convert temperature from Fahrenheit to Celsius, or you figure out based on days, years, and months how much time has passed in total. All of these things, you can express them as programs that use nothing but assignment statements and one print at the end. So get practice with that, because you're going to be using it a lot in every program you write for the entire rest of your programming career. So that is our introduction to assignment. I'll see you all in the next video.